This is your Topic 3 study guide for your Topic 3 test, starting with 3.1. Number 1, a school orchestra has 60 members. 20% of the members are percussionists. How many orchestra members are percussionists? We know it has 60 members. 20% of the members are percussionists. The question wants to know how many are percussionists. So we are looking for 20% of 60. You change 20% to a decimal by dividing by 100 because 20% means 20 per 100. You get 0.2 times 60, and then you type that in, and you get 12 percussionists. You also could solve it using a proportion. And I see that I have a typo on mine. This should be 120. Excuse me, it should be 12, just like it was before. So you can use the percent equation or you can use the proportion. Number 2, of 800 cars that drove on a street during a week, 0.75% exceeded the 25 miles per hour speed limit by more than 10 miles per hour. How many cars drove over 35 miles per hour? We want 0.75% of 800. We are going to change that 0.75% to a decimal without a percent sign by dividing by 100 because percent means per 100. And then we're simply going to type that in our calculator and get 6 drivers. Again, you could use the percent proportion instead if you are more comfortable with that. Number 3, an item sells for $40. The sales tax on the item is 8%. What is the sales tax and total cost? So to find the sales tax, we want 8% of 40. I'm going to set that up in my proportion, and I get that it is 3.2 or $3.20. That is the tax. To get the total cost, we add that tax back to that $40 to get $43.20. Number 4, when a bush was first planted in a garden, it was 12 inches tall. After 2 weeks, it was 120% as tall as when it was first planted. How tall was the bush after the 2 weeks? We're going to set up our proportion. 120 is my percent. The 12 inches is the whole amount. We're looking for the part, and we get 14.4 inches when we cross multiply. Number 5, the number of students in the marching band this year is 125%, as many as the number of students in the marching band last year. If there were 36 students in the marching band last year, how many students are in the marching band this year? We're going to set up our proportion. 125 is my percent over 100. 36 is the whole amount of students from the year before. So we get that this year we're going to have 45 band students. Number 6, Joel earns a commission of 5% on the audio equipment he sells, and the store keeps the rest. He sells a $750 amplifier. Commission is going to be your part. So we don't know the amount of the commission, but we know the percent of the commission is 5%. So we're going to put 5 over 100 because percent means per 100. We know that he's getting, the whole amount is $750, so that is my whole. We're going to cross multiply, and we get his commission is $37.50. So in order to figure out what the store keeps, we subtract that $37.50 from the total cost, and the store gets to keep $712.50. Number 7, Nixon estimates it will take him 5 hours to finish an art project. It actually takes him 320% of the time estimated. How many hours did it take him to finish the project? 5 hours to finish the art project, 320% of the time that he estimated. So my 320 is my percent because it has our percent sign, so that's over 100. 5 hours is the total. We want to figure out how many hours did it take him to finish the project. Cross multiply, we get 16. Number 8, a contaminant is found in a solution at a level of 3/500%. What fraction of the solution is this? So this is my percent, which means per 100. We know that we have 1 of the solution, so that's going to be the whole amount. We're going to put 3/500 over 100 because that's my percent. We're going to cross multiply, and that's going to cause us to have to divide by 100. Remember, when you divide with fractions, you're going to keep, change, flip. So we're going to write that 100 over 1. We're going to keep, change, and flip, and we get 3 over 50,000. 3 over 50,000 is the fraction of the solution. All right, turn the page. Number 9, a bike shop sells you a bicycle for $63 and a helmet for $21. The total cost is 150% of what the shop spent originally. How much did the shop spend originally? So first, I've got to figure out the cost of the bicycle and the helmet is $84. That is a portion of the original. We're going to cross multiply, and we get that originally they spent $56. They marked it up to 84. How much profit means that we're going to take what they marked it up to, 84, and subtract what it actually cost them, 56, and we get that it was marked up $28. Number 10, a newspaper reporter wrote an article about the amount of toxin found in a river near a factory. In the article, the reporter incorrectly used 0.25 as the decimal form of 1/4%. What is the correct way to write 1/4% as a decimal? 1/4% means 1/4 out of 100. So we're going to divide by 100 because that would be 1/4 out of 100. So that fraction bar means divide. When you divide fractions, you're going to keep change flip, and you're going to get 1/400. Then to change that to a decimal, you simply type in 1 divided by 400, and your final answer is 0.0025. His error was likely that he just found the decimal form of 1/4 instead of the decimal form of 1/4%, because this and this do not mean the same thing. One has a percent sign and one does not. Number 11. Allie and Sam are ophthalmologists. Allie found that 40% of the 170 patients she saw in a week were nearsighted. Sam found that 25% of the 236 patients he saw in a week were nearsighted. How many of the patients Allie saw were nearsighted? So we're using Allie's info, plugging it in where it goes, 40%, so 40 over 100. 170 was her total number of patients. Cross multiply to find that she had 68 that were nearsighted. We're going to do the same thing for Sam. His percent is 25. His entire amount was 236. Cross multiply, and he had 59 patients that were nearsighted. Number 12. Kevin's car can go 315 miles on 1 tank of gas. He used just under 40% of a full tank of gas to get to a sporting event, traveling at an average speed of 60 miles per hour. About how long did it take him to get there? How did you decide? 40% of 315 is 126 miles. All I do is you do 0.4 times 315, you get 126. He went less than that distance. At 60 miles an hour, it would take him about 2 hours because we would do 120 divided by 60. 13, a large university accepts 70% of the students who apply. Of the students the university accepts, 25% actually enroll. If 20,000 students apply, how many actually enroll? So this is a two-part question. You've got to first find 70% of the students who applied. So we had 20,000 that apply. So we're going to start by finding that right there by cross multiplying. We get 14,000. Notice that's an answer choice. That is not the final answer. You now need to take that 14,000 and find 25% of that number. So we're going to set that up and cross multiply, and we get 3,500, which is C. So that was a two-part question. 14, Christine has a weekend job advertising an upcoming play. She has two options for being paid. Option A is an hourly wage of $7. Option B is a 5% commission on ticket sales. She plans to work 8 hours on both Saturday and Sunday. Tickets are sold for $10 each, and Christine estimates she will sell about 200 tickets. Which option gives Christine more earnings this weekend? So part A is simply $7 an hour. She's going to work 8 hours both days. So that's a total of 16 hours. $7 an hour, she would make $112. That's option A. Option B, we have a 5% commission on ticket sales. Excuse me. So option B, we're going to multiply. Tickets are sold for $10 each. She's going to sell about 200. So we're going to first figure out she's going to make $2,000 just on the ticket sales. She is then going to get 5% commission off of that $2,000. So that's where my proportion comes in. Cross multiply. Option B gets her $100. So option A is going to give her more earnings, $12 more. All right, 3-2, number 1. A bike path is 12.5 miles. Dominic is 70% of the way to the end. How far is Dominic on the path? This is one of the fill in the blanks. We're using the proportion. The 70% is my percent, so it goes over 100. The bike path is 12.5 miles total, so that's the whole. We're solving for the part, so 8.75 is the distance he has biked. Number 2. Of 350 solitaire games that Jay played, he won 154. What percent of the games did he win? So we're looking for the percent. $350 is my total, $154 is my part. We're going to cross multiply and get 44. J1, 44 of the solitaire games he played. Number 3, a regular tube of toothpaste costs $2.50 for 3.2 ounces. A travel-sized tube costs $1 for 1.2 ounces. Compare the prices and weights using percent to decide which is the better buy. You will not have a question like this, so I'm just going to go ahead and tell you, you can do this one just by dividing the $2.50 by 3.2 and the $1 by 1.2, and you will see that the regular size is the better price because it's cheaper per ounce. Again, you're not going to have one like that on your test. Number 4, Kevin drove his car to a concert. His car can go 400 miles with a full tank of gas. He used 30% of the full tank of gas to get to the concert while traveling 60 miles per hour. How long did it take Kevin to get to the concert? Since 30% of 400 is 120 miles, and he's traveling 60 miles per hour, it will take him about 2 hours. I don't know why that's black. It'll take him about 2 hours. Number 5, decide whether the following situation is looking for the percent, the part, or the whole. The 14 compact cars sold by a dealer on Monday was 56% of the cars sold that day. We are looking for the whole amount because this is my percent and this is a portion of the cars, so we're looking for the whole. Number 6, investors buy a studio apartment for $240,000. Of this amount, they have a down payment of $60,000. Their down payment is what percent of the purchase price? So we know we're looking for a percent. That's why there's an X there. We know the whole thing is $240,000, so that's my whole. We know the part is $60,000, so that's my part. We're going to cross multiply, and we get 25%. Part B, what percent of the purchase price would a $12,000 down payment be? So we're setting up the same way, except instead of that $60,000, we're now going to use $12,000. Cross multiply, and we get 5. Number 7, when a volcano erupts, the height of the peak is reduced and the upper portion is removed. The height of a volcano after it erupted was 8,219.5 feet. This was 85% of the original height. What was the original height? So we are looking for the original, so that's the whole amount. Everything else goes where we've got the part and the percent. Cross multiply, and you get that it was originally 9,670 feet, which makes sense because it was taller to begin with. Part 8. May has 60 millimeters of a solution that is 35% nitric acid. How many millimeters of nitric acid does the solution contain? So this is the whole amount of solution. We want to know how much of it is nitric acid. We know 35% is nitric acid, so that's my percent. Cross multiply, 21 milliliters of it is nitric acid. Number 9. A perfect score in bowling is 300 points. You get a perfect score if you knock down 120 pins in 10 frames. What are the decimal value and the percent of the number of pins knocked down in relation to a perfect score? That 10 frames is there to confuse you. It's a distractor, so that's why I crossed it out. You are simply finding 120 out of 300. You get 0.4, and then you change that to a decimal by multiplying by 100 or moving that decimal place to the right, so it is 40%. Number 10, Nadia is a stockbroker. She earns 4% commission when she sells stocks. Last week, she earned $280 in commission. So that's the amount of commission. This is the percent of commission. Commission is always your part, so that's why 288 goes on top. We're looking for the whole. Cross multiply, we get 7,200 is what she sold the stock for. Part B, if she earns $14,000 in commission during the year, what was the total value of stocks that she sold? So this time we're going to use 14,000 instead of 288. Excuse me. And we get 350,000. All right, number 11. Sophie stores water for her turtle tank in a container with a maximum capacity of 64 ounces. The container is filled with 4.8 ounces less than its maximum capacity. So right now, based on that info, it only has 59.2 ounces in it. Part A, she accidentally spills 5% of the container's maximum capacity on the counter. To what percent of its capacity is the container now filled? So we want 5% of its maximum, which was 64. So that's why we're going to put 64 as the whole, 5%, cross multiply. We get 3.2, but that is not the final answer, because we need to subtract that excuse me, not subtract it. Yes, we need to subtract it from the 59.2 that is actually in the container, and we get 56. And then we need to find that as a percent of the total amount, which is 64. So we do 56 divided by 64. We get this decimal, which if we move that decimal to the right, would be 87.5%. And then part B, Sophie needs to add 16 ounces of water to her turtle tank. What percentage of the remaining water in the container does she need to use? Explain. So we're going to do 16 out of the 56 total, because that is how much we found that it still contains. And then we're going to multiply by 100 to get a percent. So it's about 28.6%. 3.3, number 1. A school drama club has 40 members. Of those students, 35% of the members are 7th graders. How many drama club members are 7th graders? Your percent is 35%. Your whole amount is 40. You would change that 35% to 0.35 and multiply it by 40, and you get 14. So 14 are 7th graders. Number 2. Greta made 36 out of 60 free throws during a basketball season. What percent of free throws did she make? The part is 36. The whole is 60. You will simply divide both sides by 60 so that these cancel out, and we're just left with the variable p. You get 0.6, which is 60%, because you have to move that decimal to the right, or you could multiply by 100, and you get 60% of her free throws were made. Number 3, a sweater normally costs $35. There's a 25% discount. What is the amount of discount and the sale price? So first part, you're just finding 25% of 35, which is 0.25 times 35, which is $8.75. So that is the amount of the discount. To figure out the sale price, you have to subtract the original price minus the discount, and you get a total sales price of $26.25. Number 4, we want 132 is what percent of 880? So we know we're looking for a percent because it says what percent. So we're going to put variable p. 880 is my whole amount. 132 is my part. To solve, we divide both sides by that 880 so that those cancel, and we're left with letter P. We get 0.15, but we have to change it to a percent by moving the decimal 2 to the right, and we get 15%. Number 5, decide whether the following situation is looking for the part, the percent, or the whole. If I look at it, I notice it says nothing about a percent. So we are looking for the percent. This is the part, this is the whole, we're looking for the percent. Number 6, Dan is watching the birds in his backyard. Of the birds he watches, 9 of them, or 45%, are sparrows. How many birds are in his backyard? So this is telling us that 9 is the 45%. So that's my part, and my percent, I'm looking for the whole. 45% would change to 0.45 because percent means we divide by 100. To solve, we divide both sides by 0.45. If you type in 9 divided by 0.45, you get 20. So there are 20 birds in his backyard. 9 of them are sparrows. Number 7, the local movie theater decides to raise the ticket prices 25%. The original ticket price was $12. Which percent equation can be used to determine the amount by which the ticket price will increase? So we want a percent equation. We know the ticket price was $12, and we know that they are raising the prices 25%. So we are looking for the part if we know that the percent's 25 and the original amount was 12. So that's going to be B. All right, and then we're going to actually plug it in and solve. And when we solve, we get 3. That's going to be the amount that it increases. So the new ticket price would be the original price of 12 plus the increase of 3, so that will be $15. Number 8. Ms. Morgan is a science teacher. She found that 30% of her 120 students are athletes. Mr. Gregory is a math teacher. He found that 27 or 15% of his students are athletes. Of the part, the whole, and the percent, which information is still unknown to Ms. Morgan? So she has 30% of her 120 students. So she has 120 students total. She's missing the part. So then we're going to find that unknown value by plugging in the percent, changing it to 0.30, multiplying it by the whole amount, 120. So she has 36 students that are athletes. Then Mr. Gregory, he found that 27 or 15% of his students are athletes. So he has the part and the percent. So we're going to plug in for the part, plug in for the percent, looking for the whole. We're going to change 15% to 0.15. We're going to divide both sides by 0.15 so that those cancel out. We're left with n. 27 divided by 0.15 is 180. So he has 180 total students. Number 9. On Election Day, registered voters go to a polling place to cast their vote. In a town, 2,703, 600 votes were cast in an election. 57% of those who were registered voted. How many registered voters are there in the town? All right, so this is the part, that's a portion that voted. We're looking for how many were registered. So we know we have a whole bunch of folks that are registered. We're trying to figure out how many total people. So that's my part. My percent, we're going to change to 0.57. We're going to divide both sides by 0.57, and we get that the number of registered voters are 480,000, even though only 273,600 voted. There are actually 480,000 that could vote. Part B, Reese claims that if 60% of the registered voters cast 273,600 votes, there would be fewer registered voters than above. Is he correct? He is correct. We would use 60% instead of 57%, and we would get that we would have 460,000 instead of 480,000. Number 10, a student answers 90% of the questions on a math exam correctly. If he answers 27 correctly, how many questions are on the exam? So that is my part and my percent. We change that percent to 0.9 or 0.90, divide both sides by that 0.9, and we get 30 total questions. Number 11, Kristen is promoting an upcoming play. She has two options for how she will be paid. Option A is an hourly wage of $7. Option B is a 5% commission on all money made during the play. She plans to work 2 days for 8 hours each day. How much money will the play need to bring in for both payment options to be equivalent? So we want them to be the same. Option A, she's getting an hourly wage, and she's working 2 days for 8 hours each day. So that would be 16 times 7, which is 112. So that's option A. Excuse me. Option B, 5% commission on all the money made. And we want them to be equivalent. So we want it to be her part that she gets to keep to be 112, just like it was on option A. So that means that her part has to be 112, and we're still doing the 5% commission. So we're trying to figure out how much money does the play need to bring in so that her part, her commission, is 112. So we would plug those in. That 5% is 0.05. We would divide both sides by 0.05, and we would get that it would need to bring in $2,240 in order for her to get the same amount of money doing option B as she did for option A. Number 12, Lindy is making reduced copies of a photo that measures 25 centimeters in height. She sets the copy machine to an 80% size reduction. Write a percent equation that represents the relationship of the height of the first copy to the height of the original photo. Since 80% of 25 is 20, then we know that 20 is equal to 0.8 times 25. That's all you have to do on that one. Part B, she wants to make another copy that will have a height of 17 centimeters. The copy machine settings increase or decrease in increments of 5%. Which photo should she make her copy from, the original or her first copy? So if we look on the left here, I have found using the original size. So if I find it using the original size, it's going to be 68%, which is not an increment of 5. If I look over here on the right, I solved the same thing, but I'm going to use that new measurement of 20 that we got over there, and that's 85%, which is an increment of 5. So that is the one we would want to use just because we want increments of 5. All right, 3-4 is all about increase and decrease. Number 1, we want the percent increase. The original amount's 100, the new quantity is 106. So if you remember, you have to find the amount that they changed by subtracting first. We get 6. And then to find the percent, we simply divide the amount that it changed by the original quantity, which was 100. We get 0.06, which is a percent of 6%, because you would multiply by 100 and get 6. Number 2, we want to decrease. Same thing again. You take those numbers and subtract to get the amount that it decreased, and then you divide by 100 to get that percent. That's going to be 12%. 12% decrease. Now, it is important to note that on this one, the only reason this matches this and this matches this is because we are dealing with an original quantity of 100. That will not always be the case. So don't think that all you have to do is subtract those two numbers and that's your percent. That is not always the case. That's only true of this one because the original quantity was 100. All right, so I didn't finish part 1. So B, we need to do quantity of 10, new quantity of 16. So that's going to be a difference of 6, which goes here. Your original goes here. Divide by your original on both sides, and that is a 60% increase. Part C, we want to go from 50 to 56, so that's going to be a difference of 6 as well, but our original is 50. We're going to divide both sides by that 50. That should have a 0 there. And we get a 12% increase. Part B, our original is 20. Our new quantity is 8, so that's a difference of 12. Our original is 20, so it goes where the whole is. We're going to divide both sides by that 20, and we get 60% decrease because we're going from 20 to 8. That's a decrease. Number 2C, we want to go from 50 to 38. So 50 minus 38, difference of 12. 50 is my original, so that's my whole amount. We're going to divide both sides by that 50, and we get 24%, and that is also a decrease. Number 3, if the original quantity is 15 and the new quantity is 19, what is the best estimate for the percent of change? You're going to take these two numbers, and you're going to find the difference. It's 4. We know our whole is our original amount, which was 15. So to solve, we're going to divide both sides by 15. 4 divided by 15 gives me 0.26 repeating, which is roughly 26.6%. And the closest one of those would be A or D. But we know that if we're going from 15 to 19, that's an increase. So you shouldn't have even looked at A and B because those say decrease. So it has to be letter D. Number 4, 360 is increased by 25%. The result is then decreased by 50%. What is the final number? So first, we're going to do this 360 increased by 25. So we're going to find 25%, and we get 90. Since it's increased, we're going to add it to the 360, and we get 450. And now they want me to cut the 450 by 50%. Now, I could do times 0.50 and then subtract, but I know 50% is the same thing as half, so I'm just going to divide by 2, and I get 225. Number 5, Emily and a friend bought 2 tickets to see a soccer game. Each ticket cost $8.25. The friends paid a total of $24.50, which included a fee per ticket for parking near the stadium. So first, I'm going to figure out the total cost of their tickets was $16.50 because they bought 2 of them for $8.25. Part A, how much did each friend pay for the parking fee? So the total amount was $24.50. We're going to subtract the cost of the tickets, and then whatever that is the parking fee, but we have to split it evenly among the 2 friends. So each friend had to pay $4 for the parking fee. B, what percent increase represents the change when parking is included in the final cost? So we know the ticket was $8.25. We know the parking fee is 4 from Part A. So we're going to find the percent of change is 0.48, about 0.48%. Number 6, 2 trials are conducted for an experiment. In trial A, the measured value is 240, while the actual value is 200. In trial B, the measured value is 195, while the actual value is 240. An assistant says that trial B has the greater percent error. Is the assistant correct? So what we're doing is finding percent error for both. Trial A is here. So in order to solve that, we subtract 240 minus 200 to get the error amount, which is 40. The original, or the actual, is 200, so that's your whole amount. When you divide by 200, you get 20%. Part B, the measured amount was 150, while the actual is 240. So the actual is your whole amount. To find that 45, we do 240 minus 195. We get 45. Divide both sides by 240, and it has an 18.75% error. So she says trial B has a greater percent error. She would be incorrect. This one has a greater percent error. Number 7, Carolyn is searching online for tickets to a concert. 2 weeks ago, the cost was $30. Now the cost is $39. What is the percent increase? So to go from 30 to 9 is a change of 9. The original is 30. Divide both sides by 30, and you get 30% increase. Part B, what would be the percent increase if the ticket agent charges an additional $4.50 fee with the new ticket price? Excuse me. So that would require us to take the $39 and add the $4.50 to get $43.50. And then we subtract the original cost to get the change. So the change on this one is $13.50. So that's my change. The original price is still $30. We get 45%. Number 8. Emily predicted her car payment to be $250 each month. Her actual car payment is $275 each month. Enrique predicted his car payment to be $200 each month. His actual car payment is $225 each month. We are simply finding the percent for each one. So let's start with Emily. Excuse me. She predicted $250, but it was actually $270. So we're going to subtract, $275. So $275 minus $250 gives me the amount of error. Then the original is $275. Divide both sides by $275. She had an error of 9%. Enrique predicted $200 each month, and his actual was $225. So $225 minus $200 to get our amount of error. The original is $225. Divide both sides by $225, and his amount of error was 11%. So he had a greater percent error than Emily. Number 9, the 7th grade class is raising money to have a class trip at the end of the year. They began the year with $1,500. Now they have $1,650 in the account. What is the percent of increase for the money the class has raised? Start by subtracting those two to get $150 as the amount of change. $1,500 is my original. Divide both sides by that original. We get a 10% increase. Part B. The class figured out that if the percent increase is 99% from the beginning of the year, the class will have enough money for every student to go on the field trip. How much money will the class need to raise for every student to go? So we need a 99% increase on that 15,000. Excuse me, 1,500. So we're going to multiply by 0.99 times 1,500. We get 1,485, but that needs to be added back to the 1,500 that they already had for a total of $2,985. Number 10, give examples of 100% increase, 100% decrease, and 100% error. Explain each. If it wants 100% increase, that means that your amount is doubling. That means your amount doubles. If it wants 100% decrease, that means you now have 0. 100% decrease, you now have 0. And then 100% error, same thing. It's either going to double or it's going to be 0. So if it's if they were 100% above, then it's going to be doubled. If they were 100% below, then it's going to be 0. Number 11, suppose the original quantity is $175 and the new quantity is $126. Write an expression that represents the percent change. Find the percent change and express it as a rational number. So this would be our equation, the 49, because we simply subtract 175 and 126, we get 49 equals percent times 175. So that's your equation. You solve it, and you get 49 over 175, which is the same thing as 0.28, which is the same thing as 28%. Those all mean the same thing. And then number 12, in the first week of August, there were 1,060 people at an amusement park. In the second week, there was a 20% decrease in attendance. The park had estimated that 1,500 people would attend the second week. What is the approximate percent error of their estimate? So we're going to start by finding the 20% of the 60,000 to get our decrease. So it's going to decrease by 212. So if it decreases, we subtract. So we're going to subtract, we get 848, which is the number of people that attended the second week. So now we need to look for the percent error for the 1,500 people. So they thought 1,500 would attend, but actually 840 attended. So we need to figure out the percent error of that. So we're going to subtract 1,500 minus 848. We get 652. So that's the amount of the error. We want the percent of the error. So that was the amount of the error. This is the actual number of people that attended. We divide both sides by that 848, and we get that it's about 77% error. All right, so now we're going to do 3-5. Number 1, a computer store bought a program at a cost of $10 and sold it for $13. Find the percent markup. You're going to start by finding the amount of the markup. So you're going to subtract 13 minus 10 and get 3. So that's my portion. I'm going to replace the original with the original cost, which was 10. And I'm going to divide both sides by 10 to get 30%. Number 2, a music store bought a CD set at a cost of $20. When the store sold the CD set, the percent markup was 40%. Find the selling price. So this time we're looking for sell price. So we can replace everything. We get 8, but that is the amount of the markup. That is not the sell price. So to find the sell price, you have to add it back to the original cost, and you get $28 total. Number 3, a store advertises a 20% markdown on a dishwasher that normally sells for $952. Find the price on sale. So we're going to find 20% to get the markdown. So $190.40 is the markdown amount. And then we're going to subtract that from the $952 to get the price on sale, which is $761.60. Part B, the markdown is the greatest possible without the store losing money. What does this tell you about the store's cost? The store's cost is the sale price. Number 4, Kevin has $24 to buy a gift for his cousin. He found a gift for $22. With 5% sales tax added on, will Kevin have enough money to buy the gift? If so, how much will he pay? So we're going to figure out 5% sales tax first, which is a markup. It's 1.1, so we're going to add that to the $22 that it cost to get that it cost $23.10 total. So yes, he can afford it. Number 5, Oliver saves 10% of his weekly earnings for living expenses. He usually makes $520 each week. This week he made 10% more. Oliver incorrectly claims that he has $520 left for spending money this week. Calculate the amount of spending money he has left for the week. All right, so the first thing we need to do is calculate how much more he makes. So we're taking 10% of that $520, and so he's making $52 more. And then we're going to add that to the $520 that he originally made to get $572. So then we need to figure out how much he's saving out of the $572, and we get $57.20. So then to figure out the amount that he has left over after he takes out savings, you subtract the original $572 minus what he plans to save, $57.20, and you're left with $514.80. Part B, what error did he likely make? He thought that 10% savings was the same thing as 10% markup, and it is not. Number 6, Brianna hoped to get 100 pumpkins from her garden this year since the weather was favorable. 20% more pumpkins grew than expected. Unfortunately, animals ate 30% of all the pumpkins that grew. How many pumpkins were left? So we're going to find 20% of 100, and we get that is 20. Then we are going to add that to the original 100 to see that it would be 120 total pumpkins. And then we need to figure out 30% that were eaten. So we're going to multiply by 30%, which is 0.3. So 36 are getting eaten. So to figure out the number that are left, we would subtract all 120 minus the 36 that are being eaten. 84 are left. So part B, is the final number of pumpkins more or less than she had hoped? It is less than, because she hoped to have 100 and she only had 84. Number 7, Gary wants to buy a video game with a selling price of $48 on sale for 50% off. The sales tax in his state is 4.5. How much will we have to pay in all? So first of all, we just figure out half of 48, which is 24. And then we're going to use that 24 to figure out sales tax is 108. So we're going to combine 24 with the sales tax. It will be $25.08. He's got $25. He cannot afford it. He will be 8 cents short, so no. Number 8, a department store buys 300 shirts for a total cost of $7,200 and sells them for $30 each. Find the percent markup. You're going to take that $7,200 and divide it by 300 to figure out each shirt is $24 each. We know they are selling them for $30, so the markup is 6. The original cost is 24. So to solve, we would divide by 24, and we get a 25% markup. Number 9, a diamond ring that normally sells for $1,275 is on sale for $1,020. A ruby ring that normally sells for $290 is on sale for $203. So what is the percent markdown for the diamond ring? This is the info for the diamond ring. We're going to subtract to get the difference, which is $255. The original price is $12.75, so we're going to divide both sides by $12.75, and we get a 20% markup. Markdown. We're going to do the same thing for the ruby ring. So the ruby ring was $290. It's on sale for $203. We're going to subtract $290 minus $203 to get the amount of change is $87. We're going to divide by that original cost of $290, and we get a 30% markdown. And then C, the diamond markdown is less than the ruby markdown. Number 10, Victor paid $415 for a new kayak that he will sell in his shop. He wants to price the kayak so that he can offer a 25% markdown but still keep a markup at 15% of the price he paid for it. What should be the price of the kayak before markdown? So we're going to start by figuring out 15% of 415, which is $62.25. We are going to subtract that from the original 415 and get $477.25. All right, if we're going to mark it down 25%, that means we're going to pay 75%, and 75% as a decimal is 0.75. So we're going to divide both sides, but the 477.25 by 0.75. He's going to need to list it as 636.33 before he marks it down. Number 11, a store advertises a sale that all items are marked down 30% or more. A life jacket is marked down from $68 to a sale price of $44.20. Is the advertisement true? So to figure out the percent, we know we're going to subtract that 68 minus 44.20. We get 23.8. The original is 68, so we're going to divide both sides by that 68, and we get 35%, which is 30% or more. So yes. Number 12, Paul bought a concert ticket for $25. He sold the ticket at a 35% markup, but had to pay the venue a 5% resale fee on the selling price. How much money did he make from selling his ticket? So first, we're going to figure out the 35% markup on 25 is $8.75. We're going to add that to the original price to get a total of $33.75. Now we need to put a 5% markup for the resale fee. So the 5% markup is $168.75. So we're going to subtract all those numbers from the $33.75, and we get about $706. All right, number 1, Lou deposited $3,500 into a savings account. The simple interest rate is 4%. How much interest will the account earn in 2 years? So we have our time, we have our rate, we have our principal. So we're just going to replace all those values, changing that percent to 0.04, multiply straight across. We get an interest of $280. Part B, how much interest will the account earn in 10 years? So now instead of a 2, we're going to put a 10, and we're going to do the same thing. Change that percent to 0.04, multiply straight across, we get $1,400. Number 2, Elsie's aunt borrows $400 with an interest rate of 1.5%. How much interest will she pay after 4 years? We're going to use our I equals PRT equation, and we're going to plug in what we know. 400 is my principal. My rate is 1.5%, so we're going to change that to 0.015. And our time is 4. Multiply straight across, you get 24. Number 3, we have $600 in a savings account with a simple interest rate of 2.5%. We want to keep the deposit long enough to earn at least $120 in interest. How many years should he keep it in, assuming he does not withdraw or add to the account balance? So this time we are given the interest is 120. That's my I. We're given my principal is 100. We're given my rate is 2.5%, so that's 0.025. We are looking for time. So we're going to multiply the 600 times the 0.25 to get 15. Then we're going to divide both sides by that 15 to isolate that in, and we get 8. So at least 8 years. Number 4, Gil borrows $8,000 for college expenses. He will pay a total of $10,280 after 6 years. Gil says the interest rate is at least 5%. Is he correct? So we're going to start by subtracting the $10,280 minus the $800 to figure out that $2,280, because that is our interest that we have to pay. So we're going to replace I with 228. That's my interest. 8,000 was my principal. We don't know the percent, but the time was 6. So we're going to multiply that 800 and that 6 to get 48,000. We'll divide both sides by 48,000 to get 0.0475, which is 4.75%. And he said at least 5%. That is not at least 5%. So this one is no. Number 5, if the principal, interest rate, or time in a simple interest problem is doubled and the other two quantities remain constant, how does the simple interest amount change? Explain. So I just assigned numbers to principal, interest, and time. I did 100 for principal, interest rate of 5%, time is 2. Not 5%, that's actually 500%. Anyway, I plugged them in and I solved them all, and I saw that all of them are going to double from my original amount of 1,000. They all double to 2,000. Number 6, make sense and persevere. Give an example of two principal amounts and 2 periods of time for which the simple interest earned at 2.42% would be equal. Explain your answer. You would have something like $1,000 as your principal for 4 years would earn you $96.80. Or you could say $2,000 for 2 years would earn you $96.80. Number 7, Theodore earned $92.40 in interest after 4 years on a principal of $550. Bella earned $216 in interest after 4 years on a principal of $1,500. Which bank would you rather use, Theodore's or Bella's? So Theodore is over here on the left. So we're just going to plug in what we know. He earned $92.40 in interest, so that replaces the letter I. 4 years is going to replace time, and $550 is our principal, so we're looking for the percent. So we're going to start by multiplying the 4 times 550 to get 2,200, and then we're going to divide both sides by that 2,200 to get 42%. So his bank is offering 42% interest rate. Bella's, we're going to plug in 216 for her interest amount. We're looking for the percent. The time is still 4 years. The principal for her is $1,500. We will multiply the 4 times 1,500 to get the 6,000. We will divide both sides by 6,000, and her interest rate is 36%. So we would rather use Theodore's because his bank is offering a higher percent. Number 8, a certificate of deposit with $600 principal earns 2.5% interest for 6 years. Select all options that would earn the same amount of interest. So we're simply going to multiply those 3 things together. We change that percent to a decimal, and we get 90. The other 2 that also equal 90 when we solve them are the second one and the last one. And then number 9, Aaron borrowed money to start a new business. The simple interest rate on the loan is 2.5%. He will pay back the loan by making a total of 12 payments of $266.50 each. How much did he borrow? So we're going to start by multiplying that $266.50 by 12 to get the total amount he's going to pay back, $31.98. And then we are going to set that up in a proportion where that $31.98 is our part. We're looking for the whole amount that he owes. This 102.5, that is our total amount. It's 102%, 102.5% because we're paying the whole thing plus an additional 2.5%. Cross multiply, and you get $3,120. So hopefully this was helpful. If you have any questions about any of the problems, reach out to your math teacher.